This is Chemistry 12, Acids and Bases Unit, Lesson 4.115, KB calculations. These calculations are very similar to 4.114, which was Ka, except in this case we are going to be using a Kb. We'll need to calculate the Kb from the Ka given in the table, so that's an important step there. And our resulting solution will be basic, so we'll have an OH minus used to calculate, not an H3O. Our first example asks us the pH of a solution of NaCN. So step one, I've written NaCN down here. This part's important, that sodium is a spectator. So when I remove my +1 ion as a spectator, Cn minus is -1. So it must accept an H. It has no choice. So when we do our ending, I'm going to make my H go that way. And my ending will be HCN plus OH minus. Okay, so as expected, this tells us that it's basic. We're going to need a Kb, and you're going to be working with OH minus concentration. Therefore, your pOH first, then, as it said in your little hints here, do as last step. pH equals 14 minus your pOH. Okay, so that's the little tricks to do with the basic. Those are your changes. Okay, now filling in our ice table. We started with 0.1 molar, so that's my initial here. Same rule applies. Make sure your zeros go in your initial line. That's all the info I have in this question. So this will be x and plus x. These will also be x, 1 to 1, and then on this side I have minus x, and this will become 0.1 minus x, and again we'll make the assumption like we did in the last one. We're going to assume this is approximately equal to 0.10 molar. That way we don't need to worry about getting a quadratic. Next we'll write our Kb expression, so products over reactants. In this case we have HCN times OH minus, all over Cn minus. Okay, so what can we fill in? We have on the top x times x, which we'll write as x squared. On the bottom we have 0.10, and then we need our Kb. So before we go on, we need to calculate ourselves a Kb. To do that, we're going to go over to our table. So I'm going to find my acid-base table here, put one in, and I'm going to read down my base side. So here's my bases, and I'm going to follow myself all the way down here until I come to Cn minus. There it is. So this is what we're dealing with. So to make this a Kb, we'll do 1.00 times 10 to the minus 14 over 4.9 times 10 to the minus 10 and get that number to use. And I get 2.04 times 10 to the minus 5, and that's what I'll put on my other page. So back to my calculation, this will equal 2.04 times 10 to the minus 5. I have carried one extra sig fig. So then I'm going to do x squared over 0.1 equals 2.04 times 10 to the minus 5. I'm going to multiply by 0.1, then I'm going to take the root. Don't forget to take the root on this one. And as an answer, you should have x equals 1.43 times 10 to the negative 3. And again, I'm still carrying around that one extra sig fig because I'm going to need to use this to calculate OH. So that is my OH minus calculation. So I've done that first. I'm just going to label this here as my step 1. And now I need step 2. Running out of room a little bit here. Actually, let's get a color that's a little more distinct as a solution. I'll follow the purple. We're going to do pOH. Remember, we're working in pOH this time. You can see I started to do pH. pOH equals negative log of OH minus. So negative log of 1.43 times 10 to the minus 3. And if you plunk that into your calculator correctly, you should get 2.85, again, still carrying sig fig. Actually, that's the right number. It should have 2. And then my pH is going to be 14 minus 2.85, which will be 11.15. That is my answer for this question. Okay, and this is a 2 significant figure, and these are my 2 significant digits. If I go up here, I can see that that should be 2 sig figs. So 2 significant digits after the decimal in a pH question. And I put a box around my answer because I had quite a bit of stuff in my question here. And I'll just label for later, that's step 2. Okay, now my next example asks the pOH of a solution of weak acid is 10.64. So I put a note over here as my starter. I've been given pOH, but the question wants a weak acid. So we're going to right away make that into a pH. So 3.36 is what I'll be working with as my pH. To finish off our equation, I started it for you. We didn't know the name, so I used HA as my generic weak acid. And you have to work in Ka because we're talking about a weak acid. And then I've got here to flip to a Kb as my last step. So if this is an acid, it's going to donate its H+, so this will become A- plus H3O+. My ice table would be 0.50 molar, nothing in the water. These are 0 to begin with. And now here, I actually have a number, so I have pH equals negative log H3O. Which means 3.36 is negative log H3O. So you're going to anti-log in your calculator. Some of your calculators, it's going to look like this. Make sure you get the negative in the right space. That's going to equal your concentration of H3O. So I will get 4.37 times 10 to the negative 4 as my H3O. And that's going to go there. And it will also go here, because these are the same concentrations in a 1-to-1 ratio. Okay, which means this is plus 4.37 times 10 to the minus 4. Plus 4.37 times 10 to the minus 4, and then on the other side we're going to do minus 4.37 times 10 to the minus 4. And I do actually want you to do that number in your calculator. So you're going to calculate 0.5 minus 4.37 exponent negative 4, and it gives you 0.4996. Okay, so you can see when we make that assumption how close we are. That's barely going to change our number. Okay, so the next step will be to calculate our Ka, which will be, I start with A minus times H3O plus all over HA. And I have numbers for everything, so 4.37 times 10 to the minus 4, they're the same, so I'll do that as squared, over 0.4996. So my Ka, once that's calculated out, will be 3.82 times 10 to the minus 7. And then this question actually wants my KB, so here's my last step here. KB is 1.00 times 10 to the minus 14 over Ka 3.82 times 10 to the minus 7, which is 2.6 times 10 to the minus 8. I have rounded to my two significant figures here, as this is my final answer, and the question is asking for KB. And you are now ready to go on to worksheet 4.15.